This is 7.4, expanding and factoring expressions. What we're going to look at first is just some multiplying and dividing. Here I have 3t times 4, and I know that gives me 12t. The reason I know that is because I know I have here 3t, and the 4 means I have 4 groups of 3t. So here's one group of 3t, 2 groups of 3t, 3 groups of 3t, and 4 groups of 3t. So I ask myself, well, how many t's do I have altogether? I have 12 t's. So 3t times 4 would give me 12t. Now I'm looking at 18r divided by 2. I know that's going to give me 9r. And I know that because here I have 18r, and I'm dividing 18r into 2 groups. So when I divide 18r into 2 groups, there's one group, here's another group. Well, how many r's are in each group? 9r. So 18r divided by 2 would give me 9r. So what we're going to take a look at is we're going to look at expanding expressions. And all expanding expressions mean is to use a distributive property to make equivalent expressions. So here we're asked to expand 2r times the sum, expand 2 times the sum of r plus 8. Well, first we have to understand 2 times the sum of r plus 8 means what? Well, this 2 tells us that we have 2 groups of r plus 8. So I have r plus 8 plus another r plus 8. And what we learned in 7.3 was how to simplify expressions. So when I look at this expression, I know I can combine my r's, and that will give me 2r. I then can combine my constants, my positive 8, and my positive 8 to give me a positive 16. This is a longer process. When an easier way to do this is just to distribute. So if I have this 2 out here, I can just take this 2 and distribute it in. And we've talked about when we distribute a number, what that means is I'm multiplying. So that means I'm taking this 2 and I'm multiplying it with my r. Well, 2 times r is 2r. 2 times 8 is 16, and I'm adding. Now, if you ask me, this is a much quicker way to do this than it would be to combine my like terms. Now we're looking to expand 3 times the sum of k plus 6. Again, what does 3 times the sum of k plus 6 mean? Well, that means I have 3 groups of this. I have k plus 6 plus k plus 6 plus k plus 6. I can then go ahead and combine those like terms and simplify it. Or I can go ahead and distribute this 3. So 3 times k and 3 times 6. Well, 3 times k gives me 3k plus 3 times 6 gives me 18. This is called expanding, and all I'm doing is I'm making equivalent expressions. So I know 3k plus 18 is equivalent to 3 times the sum of k plus 6. So in just a second, you can go ahead and pause this video and try these examples. 1 through 6, what you're going to do is you're going to expand these expressions. And remember, expand just means to distribute. Then 7 through 10, you are going to decide whether these are equivalent. Now, to decide whether these are equivalent or not, all we have to do is we have to expand the expression. And once we expand it, if both of these expressions look the same, then they are equivalent. If they do not look the same, then they are not equivalent. So at this time, go ahead and pause it and check your answers when you're done. So for 1, you should have done 3 times x, which gives you 3x plus 3 times 4 gives you 12. Here we have 6 times 2x, which gives me 12x, plus 6 times 3 gives me 18. Here we have 2 times 7, which gives me 14, plus 2 times 6x, so I have 12x. Number 4 is 5 times y, which gives me 5y, minus 5 times 3 is 15. Then here I have 4 times 4y, which gives me 16y, minus 4 times 1, which gives me 4. Here I have 9 times 5x, which gives me 45x, minus 9 times 2, which is 18. All right, so now I need to state whether each pair of expressions are equivalent or not. So when I distribute my 6 in, I get 6x plus 30. And when I distribute my 6 in, I get the same expression, which means yes, these two are equivalent. Now I go ahead and I distribute my 7 in. I have 7x plus 7 times 3 is 21. When I look at this, my 21 and my 7x are in different orders, but because it's addition, that doesn't matter. These two expressions are equivalent. All right, so I take a look at number 9. 4 times y is 4y, minus 4 times 4 is 16. Does this expression look like this one? They do not. So these expressions are not equivalent. Then I take a look here. I have 3 times y, which gives me 3y, minus 3 times 6, which gives me 18. When I look here, my terms are in different order. Well, to decide whether these are equivalent or not, I have to make sure I'm looking at my sign. So I have subtraction. In subtraction, can my terms be in different orders? They cannot. So that means no. This expression is not equivalent. So what we just looked at was expanding. So we said that 3 times the sum of 4 times z plus 1 is the same thing as 12z plus 3. Well, now we're going to look at factorizing. So when we're factorizing, all we're saying is, well, now we can go the opposite way. I can go from 12z plus 3 to 3 times the sum of 4z plus 1. So it's just like doing the opposite. We're going to go over some examples. So here I'm asked to factor 12y plus 10. Well, we know when we're factoring something, that just means that we're dividing a common factor out of the problem. So first I need to say, okay, well, what are my factors of 2y? What multiplied together will get me 2y? Well, I know 2y times 1 and y times 2 will give me 2y. Then I say, okay, what are my factors of 10? Well, 1 times 10 and 2 times 5. So now I have to compare these and say, okay, what factor do they have in common? Well, they have a 2 in common. So I can factor out a 2. So my 2 goes outside of my parentheses, and I'm working with addition. So now all I have to ask myself is, how many times does 2 go into 2y? Well, it goes in 1y time. Remember, I don't need to put the 1 as a coefficient. I just know it's there. Then I ask myself, how many times does 2 go into 10? It goes in 5 times. If I'm ever unsure, I can just check my answer by expanding this expression. So I say 2 times y gives me 2y. Check, that's right. 2 times 5 gives me 10. I know I did this correctly now. All right, now let's look at factoring 6z minus 9. Well, first I have to say, okay, what factors give me 6z? Well, I have 6z times 1, 3z times 2, z times 6, and 2z times 3. And what factors give me 9? 1 times 9, 3 times 3. I say, okay, what's the greatest factor they have? Well, they both have 3 in common. So that means I'm going to factor out a 3. And how many times does 3 go into 6z? Well, it goes in 2z times minus, how many times does 3 go into 9? 3 times. Now, I don't expect you to list out the factors every single time. What we can do is we can just look at the coefficient here and the constant here. Because they don't have a variable in common, they don't both have a z, I know I'm not going to be able to factor out a z. So I can just look at my 6 and my 9 and say, okay, what is their greatest common factor? And I know that's a 3. So we're going to go ahead and take a look at some practice problems. Please go ahead and get 11 through 16 done. All you're being asked to is to factor the expressions. Then from 21 to 26, you are asked to tell whether the expressions are equivalent or not. Once you are done with this, go ahead and play the video again to check your answers. So for number 11, I have 6x plus 3. I'm looking to find their greatest common factor. Since they don't have a variable in common, I'm just going to look at the coefficient and the constant. Well, what's the greatest common factor of 3 and 3? 3. And I have an addition problem. How many times does 3 go into 3x? That's 1x. How many times does 3 go into 3? Once. Again, for number 12, 4x and 6 do not have a variable in common, so I'm just going to take a look at the coefficient and the constant. The greatest common factor for 4 and 6 is 2. 2 goes into 4x 2x times, plus 2 goes into 6 3 times. Number 13. 8 does not have a y, so they can't have y in common, so I'm just going to look at the constant and the coefficient. 8 and 6 have a greatest common factor of 2. 2 goes into 8 4 times, and 2 goes into 6y 3y times. 14, they have no variable in common, so 5 and 10 have a common factor of 5. 5 goes into 5y times 1y time, and then 5 goes into 10 2 times. 4 and 10 have a common factor of 2. 2 goes into 4 2 times, minus 2 goes into 10z, 5z. Then number 16, 12 and 8 have a common factor of 4. 4 goes into 12 3 times, minus 4 goes into 8x 2x times. Okay, 21. If I take a look at 8x plus 3 and I factor this, I end up with, I can factor out a 2. So that gives me 2 times 4x plus 3. When I look at these two expressions, they are the same. So yes, these are equivalent. 18 plus 3y, I can go ahead and factor out a 3. 3 goes into 18 6 times, plus 3 goes into 3y, 1y. I know these are equivalent, even though the 6 and the y are in different orders, because I know in addition, the order does not matter. So these are equivalent. 5x minus 10, I can go ahead and factor out a 5. 5 goes into 5x, 1x, minus 5 into 10 is 2. This expression looks different than this one, so I know these are not equivalent. 16 minus 4y, I can factor out a 4. 4 into 16 is 4. And 4 into 4y would just leave me with y. When I look at these expressions, I see that these two are flipped, but because I'm dealing with subtraction, the order does matter, which tells me these two expressions are not equivalent. 15 plus 3x, I can factor out a 3. 3 goes into 15 5 times, and 3 goes into 3x, 1x. Again, the inside is flipped, but because I'm working with addition, I know the order doesn't matter, so these two are equivalent. Lastly, I have 12 minus 8y. I know I can factor out a 4. 4 goes into 12 3 times, minus 4 goes into 8y, 2y. When I take a look, we both factor out a 4, but the inside is flipped, and because I'm dealing with subtraction, order matters, so these are not equivalent.